Welcome to qnawire.
Welcome to question number 22.20. So this is chapter 22, go slow. So in this question we have three parts A, B and C, and each part has different charge configuration. So in part A we are given a sphere having radius zero point 0.1 centimeter, and we are given the electric field at zero point 0.2 centimeter having magnitude 480 Newton per coulomb. And we are asked to find out the electric field at zero point 0.6 centimeter. Similarly, we have in part B, instead of sphere, we have a cylinder which is having lambda charge density. We don't know the lambda, but we know that electric field due to this cylinder at zero point 0.2 centimeter is 480 Newton per coulomb. And the radius of this cylinder is zero point 0.1 centimeter. So let's say this is the radius. And in C part, we have a sheet of charge. So this sheet of charge generates electric field, and the electric field at zero point 0.2 centimeter is 480 Newton per coulomb. I have written down the formulas here. So the electric field outside means the, if you take R, so let me write it capital R, and let me write it capital R, and let me write it capital R. So not to confuse it. So outside means the electric field outside this sphere. That means R greater than capital R. So if you take any point, let's say this one, so this is R, so this R is greater than capital R. And we know that the electric field outside by the spherical charge distribution, we have 1 by 4 pi epsilon q over r square. So this zero point 0.2 centimeter is also outside, and this zero point 0.6 is also outside. So we can use this same formula to find out the electric field. So we have E1. So let's say this is E1, which is at zero point 0.2 zero point 0.2 centimeter distance. So this E1 over E2, which we have to find out at zero point 0.6. So writing down 1 by 4 pi epsilon naught q over zero point 0.2 into 10 to the power minus 2 square over 1 by 4 pi epsilon naught q over zero point 0.6 into 10 to the power minus 2 square. So this gives us, so let me go to the next slide. So E1 over E2. So cancelling all this factor here. So this goes away and this goes away, and this factor goes away, this factor goes away, this factor goes away. So we have E1 over E2 equals to zero point 0.6 square over zero point 0.2 square. And this we know that. So E1 is equals to 480 Newton per coulomb. So we can find out E2. So E2 is equals to E1 times zero point 0.2 square over zero point 0.6 square. So this comes out to be, let me write it, 480 times zero point 0.2 square over zero point 0.6 square. So this comes out to be 53 Newton per coulomb. So this is the magnitude of the electric field at zero point 0.6 centimeter distance from the center of the charge sphere. We don't need to find out the Q because we could use the ratio method here. So this is what we know, which is at zero point 0.2 centimeter, which is 480, and we are finding out the E2, which is at zero point 0.6 centimeter. So this is E2 and this is E1 at zero point 0.2 centimeter. So this radius is the information that we need to find out the electric field distribution or the formula itself. Similarly, we have for the part B. So the radius is zero point 0.1 centimeter. So we are outside the cylinder. And outside the cylinder, we have this formula again. So we can use the same technique here. So E1 over E2. So E1, we know that this is 480. So let's say this is E1. So my R1 is zero point 0.2, so this would be 1 over 2 pi epsilon naught lambda by zero point 0.2 over 1 by 2 pi epsilon naught lambda over, where are you finding out? So we are finding out the electric field at zero point 0.6 centimeters. So we need to find out the electric field at zero point 0.6 centimeter. So let's say this is E2. So we have zero point 0.6 centimeter here, 10 to the minus 2. Let me write in terms of the meter. Anyway, this factor will go away. So cancelling down the factors. So this goes away, this goes away, this goes away, this goes away. So we have, so we, for the B part, this was A part. We have E1 over E2 equals to zero point 0.6 over zero point 0.2. We know E1, so E2 is equals to E1 times zero point 0.2 over zero point 0.6, which is equals to 480 times zero point 0.2 over zero point 0.6. So this comes out to be 160 Newton per coulomb. So this was your part B. So we have found the electric field at zero point 0.6 centimeter or zero point 0.6 into 10 to the minus 2 meter. Now finding out the electric field at again, so we need to find out the electric field for the C part, which is a sheet of charge. We need to find out at distance equals to 1.2 centimeter. Now look at the formula here. So this is independent of distance. Whatever the magnetic or electric field component has in any region, so this is zero point 0.2 centimeter. So let's say this is 0.2 centimeter. So this is the same magnitude all over the space because this is independent of distance. That's why we have infinite shield of charge. So it generates same magnitude at each and every point. So at r equals to 1.2 centimeter, we have the same magnitude. So let's say E2, which is equals to at 1.2 centimeter, is the same all over the space. So we have the same number here, 480 Newton per coulomb. So that's your answer for this question. So let me write it. So let me circle it down. So for this one, we have C part here, and we have this one here for the A part, and this one here for the B part. So that's your answer for this question. Thank you for watching the video.